Hello, my name is Johan Padiolo, and today I'm going to talk about SEMGREP, a polyglot bug finding tool. And so, what is SEMGREP? So SEMGREP is a fast, polyglot, customizable, open source static analysis tool to find bugs and enforce code standard. And so it can do many things, but its main goal and where it really shines is to write custom rules to find bugs, and especially security bugs. And the main idea behind the tool is that to express code patterns, to express rules, you can use the syntax you already know, because the patterns looks like regular code. And so to make things more concrete, here is an example. So SEMGREP is a command line tool. So in a terminal, you can type SEMGREP, and then with the -L flag, you can specify the language you want to analyze. So here, OCaml. And then with the -E, you can specify the code patterns on the command line itself instead of inside a configuration file. And so here we are looking for all the code to list.map. We don't care about the function. And then we care that the second argument is a list literal. And the last argument is the directory so here dot for the current directory. And so then when you type this command, the tool will go through all the OCaml file in the current directory. And each time it finds a match, it displays it on the standard output, a bit like grep. And so here's a match at the line 2667. And actually the tool will also highlight in white the subpart of the line that was matched. And so SEMGREP supports currently 17 languages. And so most mainstream languages like Python, JavaScript, Go, and also less mainstream languages like OCaml. And the main reason for OCaml is that the core engine of SEMGREP is written in OCaml. And so we can run the tool on its code itself, on its own code. And so a few words about the history of SEMGREP. And so many of the ideas behind SEMGREP can be traced back to a tool I co-developed in academia with Julia Lawal called Coccinelle, which was a domain-specific language to express program transformation. But this tool was just for C. And then later, I joined Facebook, where I developed a similar tool called SGREP for syntactical grep, which was a simplified version of Coccinelle, and it was just for PHP this time. And then later, I joined R2C, where we designed a new tool called SEMGREP for semantic grep, which was designed from the start to be polyglot, to handle many, many languages. And so because internally, we designed a generic EST that can cover many languages. And it's called semantic because the tool knows about the semantic of the languages. And so you can write one code patterns, and even if some code are syntactically different, they will still be matched if semantically they are equivalent to the code pattern. And in 2021, actually, GitLab chose SEMGREP as the official static analysis tools to find bugs in Python, JavaScript, and TypeScript projects. And actually, we are working with them now to extend that to other languages. And so quickly, how to install SEMGREP. And so it's pretty simple. So if you're on macOS, you can just type brew install SEMGREP. Otherwise, you can use the Python package manager, pip, to install it. And so the reason we use pip is that because the core engine of SEMGREP is written in OCaml, but there's a small wrapper around it written in Python. You can also use a Docker container. And once it's installed, you can use locally. And so you can either use rules that R2C we developed, our company developed, and as well as the community. And all those rules are available on what we call the registry, the rules registry. And so here you can type SEMGREP --config, and this argument is a tiny URL that corresponds to a set of rules, and then a directory to check. And you can also use your own local rules that you can store in a YAML file. So here --config equals semgrep.yaml, which is a local file. And you can also you don't even have to install SEMGREP to try it. You can also try it online, because we developed a rule editor, a playground on the web. And so if you click here, I can do a quick demo. And so the tool is so here in the menu here you can choose the language you want to write the rule for. Here you have actually at the top, you have the SEMGREP rule with a set of fields. You have the identifier of the rule, you have the code patterns. So here we are looking for call to list.find. And then you have the message to display when there's a match was found, and the languages, here just OCaml. And then at the bottom, you have the testing code, and then you can click the button run, and then we will run SameGrep in the cloud and return all the matches. So here, this match. And so there's some good tutorial in this playground, and you can actually also click on rules to explore the set of rules available within SameGrep. And so, for example, if you type OCaml and list, you will get the set of rules. Sorry, didn't work. List. You can get you will get the set of rules for OCaml. So here, if I click on the first one, this is a rule that said you should not use list.find outside of a try. You should use list.find _ opt. And the way it's encoded is that you have the first pattern here that look for list.find with whatever after, and then it's composed with another pattern with a formula called pattern not inside that checks that we are not inside a try. And so if you are outside a try, you should not use list.find. And so back to the presentation. So the main features of SameGrep, so if I take back this simple example from the beginning, is that the main feature is that we use the concrete syntax. That is, the user doesn't have to, it's easier to use than a regular expression. And actually, you cannot even express these code patterns using regular expression, because the function argument to list.map can be arbitrarily complex with nested parentheses, and already regex are out of their reach for that. And the other way, the traditional way to write a linter for a programming language is to use a visitor that visits an abstract syntax tree, an AST. But the problem is that you have to know internally how each construct of the language is represented internally. And so it's okay maybe for one languages, but for 17, each time it's like a significant load on your brain. And so it's far easier to you already know the syntax of OCaml or Python if you want to write a Python rule. So we can just leverage that. And so you don't need to write a visitor on an EST. But internally, the tool works on an abstract syntax tree. And so, for example, in this example, there's one space between the map and the function argument. But in concrete code, you could have a new line, you could have comments between after the list.map. It doesn't matter because the tool internally works on an abstract syntax tree. Another important feature is the use of meta variables, which are prefixed with this $sign. And they are used to abstract array things like expression, patterns, types. Another feature is the use of the ellipsis operator here inside the list literal. And ellipses are used to abstract away a sequence of things, a sequence of parameters, statements, characters. And both of those features really are used to make the pattern more general. So the rule can apply to more code. Another important feature, and hence the name of SameGrep, semantic grep, is that the tools know a lot about semantic equivalences of the languages. And so, for example, in OCaml, you can call list.map, but some people may have aliased, rename the module locally with a shortcut, for example, module L equal list, and then they will write L.map. And actually, SameGrep knows about this equivalence. And so if you write L.map, we will still find a match, even if the pattern is list.map, because we know syntactically they are different, but semantically they are the same. And so the tool knows lots of knows a lot about semantic equivalence. It does a limited form of constant propagation. It knows about the commutativity of certain operators. It knows about keyword arguments. For example, in OCaml or Python, you can write a function call with keyword arguments that can be put in any order. And if in the code patterns you chose one order, it will still match code that was written in a different order, because the order doesn't matter. They are all equivalent. And the last important feature is a Boolean composition of patterns that I showed briefly before, where you can write one pattern and combine it with not another pattern and another pattern or another pattern. So with Boolean operators. And so a few advanced features of SemGrep. And so there's limited time, but an important feature that actually works only for OCaml, because it's a prototype, is to use a -LSP flag. And in that case, SemGrep will communicate with OCaml LSP, the language server for OCaml. And so here you can actually write more complex patterns like list.map, where the function argument must have this type to take an int and return an int. And so you can use type and meta variable actually in OCaml rules. And another use of LSP is that it allows us also to handle code that use open list. So sometimes people open list and then they can just call directly map. And the code pattern is list.map. And so it's not exactly equivalent, but by querying LSP, we can know that actually this map is list.map and we can report a match. Another important feature is tainting mode, where you can specify source, sink, and sanitizer using code patterns and actually Boolean composition of patterns. And internally, the tool will do an intra-procedural data flow taint propagation. And so this is especially useful for JavaScript code, for security bugs. And you can plug multiple matching engine. You can also analyze multiple language in the same file. For example, in HTML, you can have strings that actually contain JavaScript code. And so what you can do is that you can write a pattern to match a specific part of the HTML, bind it to a meta variable. So here, for example, $x. And then you can apply another pattern on this meta variable using a different language, possibly. And so, for example, in OCaml, you can have strings that contain SQL. And so we could combine the language of OCaml and the language of SQL and make a powerful semantic query on the SQL part. And so there's also a whole ecosystem around SemGrep. So I talked a bit about the registry, but there's also a dashboard with some insight. You can manage easily a set of rules on a huge set of repository. There's an agent to make it easy to run SemGrep in CI. So there's a lot more features. So I'm not going to have the time to talk about how it works internally, but something that may be of interest to the OCaml community is our use of the Tricitor library. And so Tricitor is a library that was developed at GitHub and that actually powers code highlighting in github.com, in the Atom editor and the NeoVim editor also. And so Tricitor is a GLR parser generator. And the good thing is that the community around Tricitor developed lots of grammars for lots of languages. And so for C, C++, and actually we use the Tricitor OCaml library grammar for parsing OCaml code. And so, and on top of Tricitor, we developed, actually Martin Jambon developed OCaml Tricitor, which is a tool to help generate typed EST from the untyped CST. And so hopefully we will release soon OPAM packages so that each languages of Tricitor can be a separate OPAM package so that you can easily write a custom tool for where you don't have to reinvent a parser for Python or JavaScript or whatever. And so, yes, so we are actually hiring. And so that's part of the reason of my talk. So we are a San Francisco based, we were actually San Francisco based, but now with COVID, we are quite remote. And so if you love OCaml and if you have a passion for dev tools and security, please contact us. And so we have full remote position. And so you can contact me, Pad at Return to Corp, or Martin Jambon, who joined us last year. And that's it. Thanks for watching. And so SemGrep, I just put here a few comments to make it easy to install and use. And we have also a Slack channel. And so if you have questions, we can interact through the Slack channel. And that's it. Thank you. I'm going to take questions now. Yes.